Hello students, this is a question from JEE Main 2006 from the chapter Physical Measurements. Question says, which of the following represents dimension as same as ml square by q square? So first of all, we have to check the dimension of ml square by q square, where q is the charge. So let's check the dimension of ml square by q square. Dimension of q is q is equal to I into t. So dimension will be I into t, whose dimension will be ampere into time, AT. So if you substitute AT in this, you will get ml square by dimension of q square, which is ml square by AT whole square, which is equal to ml square a raised to minus 2 ml square ml square a raised to minus 2 t raised to minus 2. This is our required dimension. So let's check one by one. First term is Weber. So Weber is the unit of magnetic flux, which we will study in the chapter Electromagnetic Induction and Alternating Currents. Magnetic flux and EMF is related as E equals d phi by dt minus d phi by dt, where phi is the flux. So EMF is work done to move a unit charge from infinity to a particular point. So its dimension will be the dimension of EMF will be work done per unit charge. EMF is work done per unit charge. So the dimension of work is force into distance. So dimension of force into distance. What is the dimension of force? Let's say dimension of E equals dimension of force into force is mass into acceleration. Dimension unit of acceleration is meter per second square. So its dimension will be L t raised to minus 2 into distance. Distance is again L. So ml square t raised to minus 2 is the dimension of E. So E into T is phi, flux. So dimension of E is ml work done per unit charge. So the dimension of charge is ampere time. So dimension will be m L square a raised to minus 1 t raised to minus 3. So it will be m L square a raised to minus 1 t raised to minus 3. And dimension of flux is dimension of E into dimension of T. Dimension of T is again T. So it will be m L square a raised to minus 1 t raised to minus 2. This is the dimension of flux. Now it is dimension of flux. So which is Weber. This is not equal to this. So our option A is not, 1 is not correct. Now check for second. What is this? Weber per meter square. What will be that? Meter square means divided by dimension of meter square is L square, which means L square get cancels. Remaining will be m a raised to minus 1 t raised to minus 2, which is not equal to this. So that is also not our option. So go for option number 3, which is Henry. Henry is the unit of coefficient of inductance, which can be related to voltage or EMF as V is equal to L di by dt. We already told the dimension of EMF as m L square a raised to minus 1 t raised to minus 2. So dimension of V into dimension of time. So we can write dimension of L as dimension of L will be dimension of voltage into dimension of time divided by dimension of current. So how can we write, which is equal to dimension of voltage is, we have talked earlier, m L square a raised to minus 1 t raised to minus 3 into t, again into t divided by dimension of current is a. So this will be dimension of L. This is coefficient of inductance. So dimension of L is, which we can write as m L square a raised to minus 2 t raised to minus 2. This is equal to required dimension. So this is correct. If we check fourth one, which is Henry per meter square, then you will get m a raised to minus 2 t raised to minus 2, which is not equal to this. So our correct answer is option number 3. This is our correct option, Henry. Thank you, students.